Okay, we are going to go over inverse trigonometric functions. So, quick search on Google tells you that an inverse is something is the opposite or contrary in position, direction, order, or effect, or something that is the opposite or reverse of something else. So, inverses are commonly confused when you're thinking about fractions. Because a lot of students will think that 2/5, the inverse of that, is 5/2. But technically, that's called a reciprocal and not an inverse. An inverse is something that reverses an operation, or it's the opposite operation. So, for instance, the inverse of multiplication is division, and vice versa. The inverse of division is multiplication. Now, give you an example. Let's say I went ahead and I multiplied 2 by 10 to get a 20. So the inverse of it would be to divide by 10. So I would start with my solution. I would divide by 10. And I will end up what I started with. So it reverses what multiplying by 10 did. And you could do the same thing with addition and subtraction. Those are inverse operations as well. So if I did 5 plus 12, that's going to equal 17. So again, we start with our solution. We apply our inverse operation, which this time is to subtract 12. And we'll go back to what we originally started with. Now, it's going to work the same way with our inverse trigonometric functions. We're going to reverse what the trigonometric functions did to our angles. So our solution is going to end up being the angle and not what the value at the angle is. So let me give you an example. Okay. So I'm going to use the unit circle. Unit circle is really useful, especially with the trig functions and inverse trig functions. So let's start with an example. So we'll do sine of pi over 6. So sine of pi over 6. If I go to pi over 6 in my unit circle, my sine is my y value, so that's going to be 1/2. Now, to do the inverse sine, so that's going to be your sine to your -1. You put in your solution, just like you did with this other inverses in the last page. You're entering the solution for the sine function, and the result or the solution for the inverse sine is going to be the angle you started with. So I'm going to just do another example. I'm not going to go through the original cosine function, but we are going to go through an inverse cosine. So let's do the inverse cosine of root 2 over 2. Okay. So I go to my unit circle. Now this time I'm looking at cosine, so I'm looking at my x values, and I find root 2 over 2. And then I look and see what angle gives me that. So the answer or solution for this is going to be pi over 4. Okay, so it's the general concept with it. There's some more specifics though. In this page, I graphed the inverse trigonometric functions. Now, because they are trigonometric functions or a function, they have to follow the 1-to-1 rule, which means that for every value of x, there is only one y. And the only way we can do this is to give them restricted ranges. Now, that might be the first time you heard a term like that, but restricted ranges just means that we put a stopping point for our y values. So looking at the inverse sine function, our range goes from negative pi over 2 to positive pi over 2. And the reason why we have a restricted range is because if I didn't put that restriction on the range, then my graph would look like this, and it would continue on. But as soon as I pass that positive pi over 2 mark, then I no longer follow that vertical line test. Then I start hitting the function twice whenever I graph a vertical line. So we had to put these restrictions on the range in order to make this a true function. Okay. So our way of notating it. If we start with an uppercase letter, then we're going to treat it like it's a function. So this is, I have them graphed right here. So start with an uppercase letter, then it's going to be a function. Okay, so I gave the 3 trigonometric functions. We have inverse tangent, inverse sine, and inverse cosine. I also wrote down the restricted ranges for you. Now, tangent and sine are the same, but cosine is just a little bit different. Okay, I also wrote down for you that there is only one possible solution. So when you put when you put a solution into the inverse trigonometric function, you're only going to get one solution out. Now, when it comes to starting with a lowercase letter, then they're no longer considering it a function, and they're just considering it an inverse operation. Okay. So, a difference between an inverse function and inverse operation. Inverse function will result in these graphs. An inverse operation, if I was to graph it, it would be when I continued this out. And it just looks like the sine, cosine, and tangent functions on their side. So if it's an inverse operation, there is going to be an infinite number of solutions. And this kind of makes sense because there's an infinite number of angles that you can put in to get a certain value out for sine or cosine or tangent. And this is because sine, cosine, and tangent are all recursive functions where they repeat themselves. Okay. So let me highlight this important. So if it starts with a lowercase letter, it's not going to be a function. Okay, there's also going to be an infinite number of solutions. Now we notate our infinite number of solutions by writing the solution as we would write it with the restricted range, and then we just add 2 pi k at the end because these functions repeat themselves every 2 pi. Of course, there is the exception with tangent. Tangent repeats itself every pi, so we would just add pi k in that case. Now, the last little piece of notes I have at the bottom, this is going to be whether it's a function or an inverse operation. The domain for sine and cosine is going to be -1 to 1. And the domain of tangent is going to be from -infinity to infinity. So let's go look at the graphs. I can show you what I mean. So the domain is your possible set of x values. And if you look at your sine and cosine graphs, they don't go before -1 and they don't go after -1, which makes sense because in the original sine and cosine graphs, their range is -1 to 1. And then tangent, it continues here and here. And I have a little preview thing saying I'm running out of time. So we didn't get to do a lot of practice here, but I hope I explained enough so you got a good grasp of the concept. And let me